Okay, once again, I forgot to start the recording, but I wanted to say that we're not doing that slide. We ended that slide last time. We're not doing that one or that one. Oh, we're not doing this one either. I don't know what happened to the skip. All right. All right. It's going to go there. And what I didn't record for last time was we played around with different trig functions, right? R equals 2 cosine theta gave us a circle, radius 1 centered at 1, 0. When we do this substitution with the basic conversion formulas, when we plugged x equals r cosine theta in for x and y equal r sine theta in for y, that boiled down to this right here. And this is what was there. And so that explains why that graph is that way. Part of what's important here is that when you graph this trig function right here, this polar function, once theta goes past pi over 2, it turns negative. And so this bottom half of the circle actually applies to thetas that are pointing in this direction here, off in this quadrant. But the radii are negative, so that means you're walking backwards into this one here. All right. Then we did some playing around with these limicons, and basically the punchline was whenever this number in front of the cosine, whenever they're the same, 2 and -2, you're going to have this cardioid situation over here. And then if that's a sine, you're going to have a cardioid like this. Right? And this is going to be R equals, say, A plus A sine theta. Right? If those two are the same, if that and that are the same. It gets more interesting if they're not the same. And so this trigonometric part right here serves to offset this constant. Because this can become negative, these constants obviously stay what they are. And it turned out if you make them negative, it doesn't change the graph. Okay? It just traces them in the opposite direction. So my point is, when these become, and they over offset, and when this b is bigger than 1, when you multiply it by the cosine, it's going to more than offset the a. And so when you're pointing in these directions out here for theta is bigger than pi over 2 to pi, it's actually going to be tracing out this loop inside. And I encourage you to play around with these on the calculator. I apologize for not having started the video. All right. But now, if you did not have the cosine part, you just had R1 equals 2, you would have that red circle right there. And what we did over here, we saw that if this b in front of the cosine is smaller than that constant, then it's never going to totally offset the constant. So the graph does not reach back to 0 ever. All right. These are fun, rose curves. And I could explain this. It's better to just let's go to our calculator and play. All right. Let's go back up here. Clear. Let's take a look at R equals, say, cosine of 2 theta. Right? Trace. Gives you 4 petals. Okay? And just so we make it prettier and bigger, let's put a 3 there. That's going to make the petals 3 times as long. Now, what's key to note here, remember cosine is along the x-axis. Your axis of symmetry is going to be the x-axis when it involves a cosine. So it starts on the x-axis. And notice that when I put a 2 theta, it gave me 4 petals. 2 theta gave me 4 petals. How about if I put 3 theta. It didn't give me 6 petals. It gave me 3 petals. So when you do cosine of n times theta, if n is even, it gives you 2n petals. If n is even, it gives you twice as many petals. If n is odd, it gives you that number of petals. Yeah, okay. And so we can play around. It's kind of fun to do these, actually, if you play a little bit. We do 7. This should give me 7 petals. Now, when I was a kid, we did spirograph. This kind of reminds me of that, right? This kind of reminds me of that. You can really get crazy and do like, oops, cosine and do 25 theta. This should have how many? 50. No, I'm sorry, excuse me. 25 petals, right? Right. It's still going. You see that? All right. And it's kind of jagged, but if you want to make it smoother, you do your window. And you see my theta step is 0.05. If I made that 0.01, they will be smoother, but it'll take longer to graph. You see how they're smoother, they're not quite as jagged. That's going to go around again. You still see it tracing. You still see it moving there, right? Still going. Right. Now, if I'm going to go back to 0.05 because that's going to be it'll be too slow for what I'm about to do. And if I go up here and I did cosine of, say, 20, that's going to give me 40 petals. Right. All right, so let's go back to some sane numbers. If we have just 2, that gave me 4 petals, right? All right. And notice it started on the x-axis. It started right here and ended there. Okay. Now let's do sine. Sine. Watch, you ready? Trace. It gives me the petals in the middle of the quadrants instead of centered on the axes. But the same rule applies. If I have an even number, it's going to give me twice that number of petals. So if I do 5 here, no, that's an even number more, 6. Right? 12 petals, right? And then if I went up and did 5, right? And now you know, since you don't have one along the x-axis like that, you know for sure you're dealing with sine here, sine of 5 theta, right? And these are at 120, what is it? They're going to be, these petals are going to be 360 degrees divided by 5. Right, so 72 degrees between these petals, right? The same thing applies, that we can make these smaller or bigger. So that is the that's the rose petals. It's actually kind of cool, right? Now, if you make the number in front of them bigger, you're just going to have longer petals, right? So that's your rose curves. And you know what? That's a good place. That's a good place to, I think, call it good, right? We will, let's see. Today's Friday. We have 2 more classes left. So why don't we not have a live class on Monday? No live class on Monday. And we will have a live class on Tuesday. So we're going to finish up chapter 10 on Monday. And Tuesday, I may do some review of my own. Keep in mind that Tuesday night is the Spark session. So I'll be available 7 o'clock, and we'll go until all the questions are answered. All right. All right. So I will first.